Welcome to educator.com. This lesson is about solving subtraction equations. In this lesson, we're going to be working with solving subtraction equations. There's some applications for writing these equations and solving them. For example, you might use an equation like this when looking at an original purchase price or for finding a change in temperature. Some vocabulary for this lesson. First off, we would use the addition property of equality. Here's an arithmetic representation. If you have 3 plus 7 equals 10, here is an equation, and the addition property of equality tells us, focus on equality, tells us that you need to add the same number to both sides if you're going to be adding a number. So for example, 3 plus 7 plus 2. 3 plus 7 is 10 plus 2 is 12. And in the same vein, 10 plus 2 is 12. So when you make sure to add the same number to both sides, you're not changing the equation because the value is still the same on both sides. And an algebraic representation could be A plus B equals C. If I'm going to add D to both sides, my equation will now be A plus B plus D equals C plus D. Remember that AB equals C, so you still have the AB and the C equaling each other, and now you've added D to both sides, keeping the equation the same. Let's look at the subtraction property of equality. Just like the addition property of equality, it focuses on keeping the equation the same value on both sides. An arithmetic representation could be 12 minus 4 equals 8. If I subtract 2 more from both sides, 12 minus 4 is 8, minus 2 is 6, and 8 minus 2 is 6. Notice that both sides of the equation are still equal because I did the same thing to both sides. I subtracted 2 from both sides, so I kept it equal. An algebraic representation could be A minus B equals C. And, actually I could say A plus B equals C. If I subtract B from both sides, B minus B cancels, becomes 0, and now I just have A, and over here I have C minus B. So in the original, when A plus B was C, now A alone becomes C minus B. So I've taken away the B, taken away the B. So now it becomes C minus B, and the A is by itself. We're going to be using these properties to solve addition and subtraction equations. And in this lesson, we'll be focusing on the subtraction equations. We're going to solve subtraction equations by adding, because adding is the inverse property of subtraction, otherwise known as the opposite operation for subtraction. Opposites or inverse operations cancel each other out. So for example, in B, minus 2 equals 2. The opposite of minus 2 would be to add 2. Because if you notice here, 2 minus 2 cancels to 0. These operations, this subtraction and this addition, have canceled each other out. So now B equals 4. Let's check our answer with substitution. I just found that B equals 4, so I'm going to take this 4 and substitute it in place of this B. 4 minus 2 equals 2. And yes, that's true. So we found the correct answer. B equals 4. Let's try another problem. 23 minus J equals 12. Now be careful with this answer because we look here and we think that we want to add 23. But remember that the value of the number is what is in front of the number. And what is in front of the number here? It's actually a positive 23. So the opposite of positive 23 is subtract 23. 23 minus 23 cancels to 0. I still have a negative here with the J. 12 minus 3 is 9. Oh, we can't do this subtraction because the signs are opposite. Never mind that. We can flip the numbers around and subtract their absolute values. So if we do 23 minus 12, 3 minus 2 is 1. and 2 minus 1 is 1. So since this has a larger absolute value and it's a negative, my answer is going to be negative. So negative j equals negative 11. And we can take off both the negatives, making it j equals 11. So remember here that you don't focus on the sign, rather you focus on the value of the number, which in this case was a positive 23, and that's why we subtracted 23 from both sides. Solving an equation by adding. Once again, a minus 7.9 equals 17.9. Well, now let's try it with a decimal. The opposite of minus 7.9 is to add 7.9. 7.9 minus 7.9 cancels out to 0. 9 plus 9 is 18, carry 1. 14, 15, carry 1, 2. Bring down your decimal, 25.8. Let's go back and check our work. Let's use substitution. Let's put 25.8 in place of this a. 25.8 substituted here, minus 7.9. And if we did that correctly, we should get our answer 17.9. 18 minus 9 is 9. I've borrowed. 14 minus 7 is 7, and I've borrowed, and that's a 1. 17.9. And yes, we did it correctly. So the value of a equals 25.8. Let's try our next equation. Negative 5.6 plus x equals 10.2. The opposite of subtracting 5.6 here is adding 5.6. Those cancel to 0, and my variable has been isolated. X is alone, and here we add these numbers. 6 plus 2 is 8. Bring down your decimal. 10 plus 5, 15. 15.8. Let's use substitution and check our answer. I'm going to substitute 15.8 in place of this x. So negative 5.6 plus 15.8 equals 10.2. Notice that my signs are opposite, a negative and a positive. That means I'm going to subtract the values. 15.8 minus 5.6. 8 minus 6 is 2. 5 minus 5 is 0. 10. 10.2. And yes, it's the same. So we did it correctly. So my answer is x equals 15.8. Let's solve an addition equation by first writing the equation from a word problem. You withdraw $42 from your bank account and your balance is now $635. How much did you have before you made the withdrawal? So remember that your variable equals what you don't know. So our unknown is how much we had before we made the withdrawal. So let's call that our total in the bank. Initially we had, you can call it any variable you want. I'm going to say initially I had T amount. I had the total amount. Then I withdrew $42. And now my bank account has $635 in it. The opposite of subtracting 42 is adding 42. 42 minus 42 cancels to 0, and T equals 776. So originally I had $677. Let's check and make sure our answer is right. If I started out with $677, then I withdrew, I took out $42, I should be left with $635. 7 minus 2 is 5. 7 minus 4 is 3. Bring down the 6. So yes, that's right. So I did my problem correctly. So I began with $677. Let's look at the question and the answer again and make sure we answered it correctly. How much did you have before you made the withdrawal? So initially, we had $677. A healthy person has a normal temperature of 98.6 degrees Fahrenheit. Suppose a sick person needs to decrease his temperature by 2.5 degrees Fahrenheit to return to normal. Use an equation to find the sick person's temperature. So right now, this person is sick and he has a fever. He's a little bit higher than normal temperature. He's no longer at 98.6, but he's in fact up by 2.5 degrees. So let's use an equation to find the sick person's temperature. So this sick person, his temperature is, let's call T for temperature. If we decrease his temperature, subtract by 2.5 degrees, we'll return to the normal healthy temperature of 98.6. So the opposite of subtracting 2.5 is adding 2.5. Let's add 2.5 here to the healthy to see where our sick person is. T equals 6 plus 5 is 11, carry 1. 10, 11, carry 1. And he's at 100. I moved it over to the side a little bit. Here, let me rewrite that so you can understand it a little bit better. 6 plus 5 is 11, carried 1, 8, 9, 10, 11, and then 9 plus 1 is 10. So this person is at 110, oops, that's not a good temperature. This person is at 101.1 degrees Fahrenheit. So he's got a slight fever, and let's check our answer. If he is at 101.1 right now, and we take away the 2.5 degrees, will he be back at 98.6, the healthy temperature? 11 minus 5 is 6, I borrowed. So 10 minus 2 is 8, and I borrowed, so it's 9, 98.6, and yes, that's correct. So let's use the equation to find the sick person's temperature. When they specifically ask you to use the equation, they want you to set up the problem. So here we show that we have set up the original equation, T minus 2.5 equals 98.6, and we've also found the temperature. It was 101.1 degrees Fahrenheit. Let's try an example of just an equation. 12.3 equals x minus 8. The opposite of subtracting 8 is adding 8. Remember with the decimal, if you don't see a decimal, it comes after the number. So I'm going to line it up. 3, 8, 9, 10, and 2. So I've got an x, and algebraically we usually write the variable first. X equals 20.3. Remember to check your answer using substitution. I'm going to come back to the original equation and put in 20.3 and see if my answer will check out. 20.3 minus 8, line it up correctly, 3, and 20 minus 8 is 12. So yes, 12.3. So our answer is x equals 20.3. T minus 2.8 equals 8.5. The opposite of subtracting 2.8 is adding 2.8. And the addition property of equality tells us we must do it to both sides. Line up your decimal. 2.8 minus 2.8 cancels to 0. And T equals 8 plus 5 is 13. Carry your 1. 10, 11. Remember to bring down your decimal. 11.3. Let's check our answer using substitution. I'm going to put the 11.3 in place of the T. 11.3 minus 2.8. 13 minus 8 is 5. We borrowed, so 10 minus 2 is now 8. And yes, it checks out. So T equals 11.3 is our answer. Let's solve this subtraction equation by writing the equation. You take a trip to the mall and buy a few shirts. The total cost is $68.95. You still have $13.55 left after you pay. Write and solve an equation to find how much money you had before this purchase. So they want us to both write and solve the equation. So let's try to set up our equation here. What we don't know is how much money we had before the purchase. So that's going to be our variable. So let's call that our original money. I'm going to call it M. So originally I had M dollars. I went to the mall and I bought some shirts and I paid $68.95. So from my original money, M, I spent $68.95. And now I am left with $13.55. So here I've written the equation. I've taken care of that part of the problem. Let's solve it now. The opposite of spending $68.95 or subtracting $68.95 is adding. So if I made the return, I would get back to my original amount of money. So According to addition property of equality, let's add to both sides equally. These cancel out to 0, and I've isolated my variable. I'm now back at my original amount. Remember to line up your decimal. So I began with $82.50 when I went to the mall. Let's check our work. If I had $82.50 and then I spent $68.95 on the shirts, if I did this correctly, I should be left with $13.55. 10 minus 5 is 5. I borrowed. 14 minus 9 is 5. I borrowed. 11 minus 8 is 3. And I borrowed, so 7 minus 6 is 1. So that's correct, $13.55. So initially, I had, before this purchase, $82.50. So I've both written the equation here, and I've solved it by finding the original amount. The owner of a used music store bought a compact disc for $5.25. When she resold it, her profit was $4.35. What was the selling price? Okay, so we're looking for the selling price. So if you take the selling price, her original selling price, let's call that S, and we subtract her profit, how much she made, that will reveal to us the original price of $5.25. You add $4.35 to both sides. I cancel that to 0. And here we have 10, carry 1. So that means she sold it for $9.60. After she sold the disc for $9.60, she was able to make an extra $4.35 after she took out the money that she originally paid. Let's check our answer. If I take $9.60 and I subtract $4.35 her profit, I should be left with what she originally paid. 10 minus 5 is 5, borrowed. 5 minus 3 is 2, borrowed. 8 minus 4 is 4. Oops, we did something wrong here. We should be coming up with 525. So I add 435. So over here, let me check this answer. 5 plus 5 is 0. Carry 1. 3, 4, 5, 6. And then 5 plus 4 is 9. So S equals 960. Oh, because I did not need to borrow here. That's why. Okay, let's change that. All right. So 6 minus 3, we did borrow, so that is 5 minus 3, which is 2, and then 9 minus 4 is 5. Okay, 525, good. So it was really good that I checked my problem there. Okay, so we did come up with the original price, 525. There's another way that you could write this equation. You could take her original selling price, subtract what she paid for the disc, and that should give you your profit. So if we add 525 to both sides, those cancel, S equals, and then add this, 10, carry 1, 4, 5, 6, 9. So 960. And once again, our answers match. So this is a part-to-part, part plus part equals whole type of problem. So part of the money, part of the total price, which was $960, was how much she paid for the disc. She paid $525. And then part of the total price, the other part, was how much her profit was, which was $435. So either way, if you take away what she paid from the total, you're left with the profit. Or vice versa, if you take away the profit, you're left with what she paid. Thank you for watching educator.com.